This is a Lagrange multiplier question where you have to compute the gradient of the given function and the gradient of the constraint. This constraint. I'll call this G, and we're going to find the gradient. Now, gradient is the vector obtained by finding the partial derivative with respect to x and then y and then z. You get three numbers and then that becomes a vector, three functions. If you differentiate this by x, that's the partial derivative by x, it means you treat y and z as constants, so they become 0, and the derivative of negative x squared is negative 2x. If you differentiate this by y, now x and z is considered as constants, so you just get 2. Differentiating this by z gives you negative 4. And for g, differentiating by x gives you 8x. And then by y it gives you 2y. And then by z you get 2z. Now, Lagrange multiplier says you have to introduce this lambda multiplied to the constraint. And if you look at what they are, what this equation is, you get this on the left side, and you get lambda times 8x, 2y, 2z. And the trouble with this is that having lambda multiplied to x and then y and z makes it harder to solve. And if you proceed like this, your value of lambda will be harder to get because you have to divide and all that. So one nice strategy in solving problems like this is to actually just say this is a tilde, and then divide this over. And then make sure that lambda tilde cannot be 0. If this is 0, then you would have 2 equals to 0, so that doesn't make sense. So I know that lambda tilde cannot be 0. And if it's not 0, you can divide and make it look like 1 over lambda tilde, negative 2x, to negative 4. And we're really not interested in the value of lambda. I could have, or the name of lambda. It's just, this condition just says that the gradient of f and gradient of g, those two vectors should be parallel to each other at the point where this function is maximized or minimized. That's all it says. So what we're going to do is we're just going to rename this as lambda. And then we have a much better equation to handle. Now, if your professor's someone not me, then you should definitely ask your professor if it's okay to multiply lambda on the left side. It's certainly possible if you can show that the gradient of f can never be 0, in which case it's like if it has any kind of a linear term, then if you just have some number times y or number times z or number times x, and that's the only x or y, z term, so that when you find the gradient, if you have any constants here that's not 0, then you can definitely put the lambda on this side. And actually that's preferred. If you see any constant in one side, just multiply lambda on that side. That's like the shortcut. Okay, so let's assume that this is true. Now let's proceed. What does that mean? Okay, lambda times negative 2x, 2, and then negative 4 should be equals to 8x, 2y, 2z, which means lambda times negative 2x equals to 8x. See, lambda gets multiplied, and they have to be equal to 8x, 2y, 2z, so the next one would be saying 2 lambda equals to 2y, and negative 4 lambda equals to 2z. And see, this one will be y equals to lambda. This will be z equals to negative 2 lambda. But what about this? Well, that one, first let's divide by 2. So you get negative lambda x equals to 4x. And then I want to move this lambda x to the other side, so you get 4x plus lambda x equals to 0. So I moved it to the other side and switched places. Hopefully that didn't confuse you at all. Once you do that, then you can factor the x out, which makes you say that either 4 plus lambda is 0 or x is 0, because if two things multiply to 0, at least one of them has to be 0, right? So you have these two possibilities, and the challenge here is to track down each separate case, and that takes some patience. That's like the number one change. Now there's another thing that I should have said before doing this. If you look at this system of equations, you have 3 equations for the 4 unknowns, x, y, and z, and then lambda. This is not desirable because we know that in order to find 4 different variables, you need 4 equations. So where is this 4th equation from? Well, it's the constraint that's going to be added here. So it's really important to write the constraint one more time so that you don't forget that's part of the system you're trying to solve. Okay, often people get stuck in Lagrange multiplier questions because they forget to use the constraint. Okay, all right, good. So now what do? We should now track down each case. So case 1 is when lambda plus 4 is 0, or lambda equals to negative 4. If you solve this, you get lambda equals to negative 4, right? In that case, what do we know? Because we know that y is lambda, y would be negative 4. And then z is negative 2 lambda, negative 2 times negative 4 would be positive 8. And what about x? How do you find x? Well, we can plug it in here, right? So 4x squared plus negative 4 squared plus positive 8 squared equals to 125. 8 squared is 64, negative 4 squared is 16. 16 plus 64 gives you 80. Subtracting from 125, we get 4x squared equals to 45. Take the square root both sides. Now be careful. If you take the square root both sides, you get plus or minus square root of 45. And that would mean that x is plus minus. There's a 9 inside 45, right? 45 is 9 times 5, so 9 can come out as 3. And then you have to divide by 2. Now what this tells us is that the points that we get are, let me put in another color. We could have x as 3 radical 5 over 2, and then y to be negative 4 and z to be 8. Or you could have negative 3 radical 5 over 2, negative 4, 8. So these are possible places that we have to look for when we consider max or min. Now, Lagrange multipliers gives you all the possible candidates. So having these numbers as a solution to this system doesn't mean automatically that they are the max or min. You still need to investigate whether it does produce a big number or a small number. Okay. All right. Then the next one that we should do is now the other case when x is 0. Now, if x is 0, then the equation 4x squared plus y squared plus z squared equals to 125 would have this to be 0, and therefore you just get y squared plus z squared equal to 125. But we also had, let me put this as case 2. We also had y equals to lambda, right? Before we had y equals to lambda and z equals to negative 2 lambda. We can plug these in, and what we get is lambda squared. Negative 2 lambda squared, negative will become positive, and negative 2 squared will be 4. And then you get lambda squared equals to 125. 1 plus 4, that's 5, so you get 5 lambda squared equal to 125 divided by 5, which gives you lambda squared equals to 25, which gives you lambda equals to either plus 5 or negative 5, plus or minus 5. Okay, so in this case, what are the solutions? Well, plugging in 5 in here, you get 5 and negative 10, right? So one solution is 0, 5 and negative 10. And then the other solution is, if lambda is negative 5, then y equals to lambda, so y will be negative 5. On the other hand, negative 2 times negative 5 will be positive 10. Okay, now in addition to what we have here, we will also investigate 3 radical 5 over 2, and negative 4 and negative positive 8. So negative 4, positive 8, and then negative 3 radical 5 over 2, negative 4, positive 8. So these are all the possible solutions. Okay, so on here, let's look at f of 0, 5, negative 10. That will be, you get 0 into x. 5 times 2 will be 10. And then when you plug in, this is the value for z, right? X and then y. So when z is plugged in as negative 10, negative 10 times negative 4 gives you positive 40. So you end up with 50. On the other hand here, if you plug in 0, negative 5, positive 10, still x being 0 doesn't do anything, but these numbers are both negated, so you're going to end up with negative 50. On the other hand, when x is 3 radical 5 over 2, this actually came from the fact that 2x squared, or 4x squared, is equal to 45, right? So using this fact, we can rewrite this as 45 minus 45, and then let's plug in negative 4 here. Negative 4 times 2 is negative 8. And then 8 times negative 4 gives you 32. So that's 40, so that's negative 95. And because the 2y and negative 4z will be same, but and also that 4x squared will still give you, oh sorry, I just made a mistake. This should have been just x squared, right? So this should have been 45 over 4. Okay, so this should have been 45 over 4. Yeah, because if you divide by 4, so if you just square it, then you get 45 over 4. And then 45 over 4 is, that's 11.25, so negative 51.25 is what you get, okay? And this one will give you the same value, all right? So, it's asking for the max and min, and therefore we're ready to get the answer. When does this f attain maximum? It's one of these candidates, right? And because 50 is the highest among these candidates, it must be this one. So the max would be at 0, 5, negative 10 with with f being positive 50. And minimum will be at plus or minus. Both are actually minimums. They both give you the same exact minimum. So we have a tie. In that case, you should put both, with f being this time negative 51.25. Okay, so that's how you solve this. So it is algebraically challenging. A lot of problems in Lagrange multipliers end up being just a system of equations that's really annoying to solve. So you should try to do as many questions as possible here so that you can figure out how to solve these complicated algebraic systems.